Good morning, good afternoon, wherever you are. Everyone, thank you so much for taking time to join us today on this interesting webinar, which is called Supply Chain Attack Fundamentals, where um, we will go deep into how hackers find vulnerabilities in third-party components across your websites, APIs, applications, and use them as backdoors to hack into your applications. So before we get started, a couple of housekeeping notes. We have poll questions throughout the webinar to keep it interactive. Please answer them so that we can weave that into the story and then discuss it. And the second thing is we have a Q&A button at the bottom of the webinar. So feel free to ask your questions um, anytime you have, but we will get to them as and when we complete the session. So without further ado, let's get started. So I am Phani. I am VP of Marketing at Indusface, and I have with me Vivek Gopalan, who is the VP of Products at Indusface. Right. So Vivek specializes in building highly complex security software products. At Indusface, he's been here with us for more than 8 years now. Um, Building our web application and API protection platforms, as well as the Indusface VAS, which is a dash scanner. And prior to that, he worked for many more years in endpoint security. So a couple of slides about who we are. So we are Indusface. So we are a purely application security company trusted by 5,000 plus customers across 95 countries. So we offer three application security platforms. So what we will cover today is the first one, which is on application protection. So Aptrana is our flagship product, which is a web application and API protection platform. We also have Indusface VAS, which is a dashed scanner. And we also bundle in penetration testing for websites, APIs, and mobile applications. No matter what your compliance requirements are, we have you covered. So should you have any questions, reach out to us. And over the years, we've been recognized across forums. A couple of badges that we are extremely proud of are the Gartner Peer Insights Customer Choice. So we are on the top right. And we've been there for 3 years in a row. And even in the SME segment or the SMB segment, we are a leader in the G2 quadrant, and we have a number of badges like users, lovers, and best ROI, and so on. So this slide we've already discussed. We are trusted by 5,000 customers across 95 countries. Now this is just a representative sample of customers across various industries who trust us. So should you need any reference call if you want to work with us, we'll be more than happy to provide one. This is something that we already discussed. But one thing that I want to call out is, see, as you see, we are here listed on the top right. Even here, we are the only one with 100% customer recommendation rating. So we are almost like a leader of leaders in this quadrant. Then on Aptrana network, we process trillions of requests every quarter, and based on that data, we publish the State of Application Security report, where we talk about what attacks are being employed by hackers to target your websites, APIs, and mobile apps. Now we have interesting dissections on enterprise versus SMB, banking versus healthcare, and so on. So we see that different industries and different companies based on the size are being targeted by different tactics. So a lot of findings in the report that we have here. This has been covered by various print and other dailies. Now, with that, we will come to the agenda of today's session. So Vivek will take you through what supply chain attacks are. What are the challenges faced when you try to mitigate supply chain attacks, how to prevent supply chain attacks, and more importantly, this is something that is fast approaching. Next year, early next year, in the Q1 of next year, PCI 4.0 compliance is going to be mandated if you process credit cards on your websites. So this requires you to have some sort of a protection on web browser based supply chain attacks. We'll talk about that also in the presentation today. So with that, I'm passing it over to Vivek. Vivek, over to you. I'm stopping my screen share.
Yeah, thanks, Phani. Thanks. I'll just share my screen and then get started. Let me know if you can see my screen.
Yes.
Okay. Thank you. Thanks, everyone, for joining in for today's webinar. So let's get started. So we have some interesting topics to discuss. So let me start by talking about what is a supply chain attack. So supply chain attack is, as the name suggests, it is an attack that is happening on your supply chain. So what do I mean by that? So if you have an application, your application is not just the code that you have written. There are various third-party components that is being used. You might be integrating an open source platform. You might have an open source component into it, like even every Java. The Log4j example comes to my mind. So when these kind of third-party components, or if you have any tools integrated into your application for analytics purpose, your heap.js or anything like that, right? So these are your third-party components. And attack on these third-party components to get access to your applications or your system or the data that you need to be protected is called as supply chain attack. So instead of exploiting the weakness in your application, the weakness of the third-party components that is used by your application is exploited as part of this supply chain attack to gain access to your systems or applications. So why is it a concern? It's a concern because this is a form of attack that is ever growing. Gartner has predicted that by 2025, nearly 50% of the organizations would see some form of these attacks, right? And one of the recent study in about 350 organizations in US and Canada, 90% of the respondents have said that they have seen some form of supply chain attack in the last year. So this is something that is fast growing. Even in this year, one of the studies says nearly 180,000 attacks have been seen, which is nearly already a 50% growth year on year. So what are the types of supply chain attacks, right? So as I said, supply chain attacks are essentially attack on your third-party components, third-party websites, and the likes. So how is hackers exploiting this, right? So there could be various ways. So one is you have integrated an open source component. You have integrated your open source platform like Joomla, WordPress, or whatever. Now that has a vulnerability. So these vulnerabilities you have no control over, right? It's vulnerability because of some code changes done by the third-party component. But this vulnerability is part of your application, and now attackers can exploit these vulnerabilities and hack this. So that is one form of exploits. A common example for this is a Log4j. There was a vulnerability in the Log4j component, which was widely used in all the Java applications. So even though the application as such was well written without any security issues, this Log4j vulnerability, which was part of a third-party component, eventually made all these applications vulnerable. So that's one form of the attacks. The other form of supply chain attack could be that there's a third-party platform, and those platforms passwords are compromised, right? And unfortunately, all users reuse their passwords. So taking those passwords, getting those, and then using it to gain unauthorized access to privileged data in your application. So that's one form of supply chain attack. Such attacks are very common. There is a lot of leaked password databases that is available in the dark web, which is constantly used by hackers. The other form of attack is also quite common, which is using the misconfiguration in your infrastructure layer, right? Especially when you're using cloud service providers like AWS or likes, how those services are configured. Is your S3 bucket public? Is your S3 bucket private? All these things becomes important, and because of the fast-paced development cycles, it is very common that any of these misconfigurations remain public. And there are a lot of cases where such misconfigurations has been exploited by the hackers, leading to compromise for the organization. The last but not least is the most common type of supply chain attack, which is the browser-based attacks. In the browser-based attacks, what happens is you are loading a third-party component at the client level, at the browser level. Say you're loading a JavaScript. Now, because you are loading it from a third-party server, as a security organization or as application owner, you would not have any visibility onto what is happening in this JavaScript because these are running at the browser level. Now, if this JavaScript is compromised, that can uh, lead to leakage of the data that is given by your users to your application at the browser level. So that's essentially a browser-based attack, which is a man-in-the-middle attack, which is common type of attack. The mage cart attack and those things fall into this category. So some of the recent studies or recent attacks around this, these are some of the examples. The major reason of showing this is no matter you're big or small, everyone is prone to these types of attacks, right? The polyfill JavaScript vulnerabilities you might be aware of. Because of that, it was a supply chain attack, and because of that, lot of big brands were compromised, including Warner Brothers and the likes. Airbus is a common example of the leaked password kind of situation where its partner or its a Turkish airline, their password was compromised, and through that, hackers were able to get access to the Airbus data and get a lot of employees' data and the likes. Microsoft was compromised because of JFrog vulnerability. Norton was compromised due to the vulnerability found in the MOVEit. So the major point by this, and the point that I wanted to drive is this is very common. This is something that everybody is facing, and it is something that every organization and every security practitioner should take seriously. So before we go further, a quick poll question on around how confident are you in addressing the supply chain attacks? The poll will start now. We'll give you a couple of minutes to answer this poll. We'll close the poll now. You can close the poll, Manju, and publish the results. Great. About 50% of you have said that you are somewhat confident, and 50% have said no, they are not confident. So I think that makes a lot of sense. It's an evolving space, and you should keep looking at and seeing how you can improve your confidence and protect you against these kind of attacks. Hopefully, this session gives you some information on how you can go about doing the same. So, why is it a challenge, right? Why is supply chain attacks or protecting against supply chain attacks a challenge? The major reason is because of the visibility challenge, right? You as a security practitioners know what is your applications, okay, and you can have controls policies in place to identify the vulnerabilities that are part of your applications, have controls to protect those. All those things is in your hand, but you are very much blindsided when it comes to understanding the third-party components that is used part of the application. Very rarely do security practitioners, application owners do have complete inventory of all the third-party components. Uh, and it is also because there are various players in the organization which influence this. Sometimes developers use some third-party components, sometimes marketeers to capture analytics, they will use it. Sometimes product managers will integrate some JS. So all in all, as a security practitioners, you will not have complete visibility of all the third-party components that is there. So then what happens is, because there is lack of visibility, there is lack of understanding of whether these components are vulnerable or not vulnerable. There's lack of visibility into any new compromises that is happening in this third-party world. So a lot of these exploits or vulnerabilities go unnoticed for a long period of time. Also, it is very few solutions help you protect against these third-party components. They don't have ability to patch these vulnerabilities. So eventually, all in all, it becomes a really big challenge for you to understand the inventory, get visibility into it, get understanding of the risk of these third-party components of posting, and then protect against those. So that's pretty much the challenge. So how can we, as part of Aptrana, can support you? So as part of, we talked about the various types of supply chain attacks. Most of these attacks are already by default protected, which is say the open source uh, vulnerabilities, right? So when Log4j was introduced, within couple of days, we were able to publish the policies to protect against this. So any application that was behind us was protected. Even though the vulnerability was there in the application, we had a virtual patching at the PAF layer, ensuring that all the sites behind us, thousands of sites behind us, were protected from the Log4j attack. Uh, when it comes to leak passwords and the likes, we have a strong account takeover protections. We have protection against credential stuffing attacks, login protections and the likes. So enabling those would help you protect against the leak password and those variants of attacks. Misconfiguration of your infrastructure again gets by default protected, because when you onboard your site behind Aptrana, we become the front end for your application, and essentially uh, the misconfigurations are not available or not visible to the external world. So automatically these protections kick in. Uh, the major challenge then still remains is the browser-based attack, right? Where an attack is happening at the browser level because of the JavaScript components that is loaded at the browser level, and which you have no visibility upon. And for this, you need what we call as the client-side protection, and that's pretty much what we are going to talk about for the rest of the webinar. So let's go about first trying to understand how a browser-based attack works, right? So I imagine I'm your end user, and I'm the end user.
Okay, looks like there is some intermittent issue.
Included. So what happens?
So we lost you for let's say about a 20 seconds. So if you could explain
Okay,
this slide again. Yeah.
okay, great. So what I was saying was, imagine I'm the end user, and as an end user, I'm trying to log in to your, or trying to access your website. I open your website in the browser. Now, your browser or your application is loading a third-party JavaScript, right? It could be an analytics JavaScript, right? So that is getting loaded. Now, as part of your application, I have to give a credit card details. Now, this credit card detail is stored by your in your browser, and the JavaScript just sends the analytics back to the third-party server. So this is your this imagine this is your application state. I'll also show it as part of the real life scenario. So this is a imagine this is your web application. I'm the end user. I'm loading it. I'm going into to the cart. As I log in, you can see certain JavaScripts are loaded. These are legitimate, trusted JavaScripts by you, by your application, and you want these JavaScripts to run. So at this point, there is no compromise, right? I'm giving a password, I'm giving my credit card here, and there is no problem from that perspective, right? The credit card is stored in your application, nothing happens, just the analytics gets the right data, what they want to give. Now, what happens when it comes to a third party compromise is that hacker essentially goes and looks at what is the vulnerability in the third party server. They might use various ways, exploit a vulnerability that is there as part of the third party component, or they could do social engineering. Let it be anyways, right? At this point, you have no control, you have no visibility of this space. So by some means, the JavaScript is injected into the third party server, right? And again, I'm emphasizing at this point, you have no control. You don't know where the third party server is and everything. So there's no way you can protect against this. Now, imagine I, as an end user, again load your website. Now, but when I load a website, the trusted JS is loaded and also the malicious JS is loaded, right? And when I'm not suspecting that there is anything wrong here, so because the JavaScripts are invisible, I go and provide my credit card. What happens is the analytics.js would give the right data to the third-party server, but this malicious JS was sniffing here, and it will get the credit card data and send it to the hacker. So that's essentially what is essentially the attack here, right? An injection is happening at the third-party server. You are not aware of the as an end user. I load it. I am not also aware of the JS that the malicious JS is loaded. You as a security practitioner actor also do not have the visibility here. I give a credit card. The credit card goes to the hacker. This is essentially the man in the browser kind of an attack, right? So let me show that. Now I have a site, the similar site. Now this similar site is connected to the vulnerability third-party server. So the third-party server is already compromised. So now when I log in as an end user, what happens is, if you can see, for an end user, he is only seeing this. The functionality is the same. But if you look deeper into the network packets and everything, you can see that sneakily a stealer.js is also added. So now the stealer.js is essentially loaded from a sniffer uh, malicious server, and it is sending data to essentially this. So at this point, there is no credit card details available at that. Now, if you see, if I give my data here and say I am saying I am hacked 1 to 26, 1 to 1, and save it, the credit card data is saved. But if you come here and see this, oops, 1 second, there is this thing. Sorry, I am seeing an issue here. Give me a minute. Okay, my stealer.js is here. Let me just write this. Okay, let me again do this. Hopefully this works. Otherwise, somehow my demo is screwed, but I believe you got the idea anyway. Uh, my credit card data is saved. I think my Stealer.js would have sent the data. I should get this data now. Oops, I'm not getting it. But anyway, the idea is this: it should have been sent to the server, and see the API server there should be showing it. But I hope I was able to explain the gist of it to you. That what happens in these cases is that the credit card detail gets what is happening? There's something wrong. That's why this is going for a toss. But anyway, give me a minute. Okay. So that's pretty much what I wanted to say. The credit card gets sent to the hacker here. Now, how do we protect against this, right? So to protect against this, what happens is uh, what we do is, as part of Aptrana, when the site is onboarded behind Aptrana, we know this is the right state, right? When you onboard behind the Aptrana, we learn this state. And then we show you the inventories of all the JavaScripts, from which domain it is getting loaded and everything. So what happens is we are sure about uh, we are doing the inline learning of your application and of your trusted behavior. And we will show this trusted behavior to you, and you can approve that, yes, this is my trusted behavior, and enable the client-side protection. So then what happens is, every time any user tries and onboards or tries to access your site, we will always see, is this trusted behavior being seen in your application, right? So when the actual attack happens, like what I showed, what will happen is, now because the site is behind Aptrana, the Aptrana protection is there. When you try to load it, because malicious script was not part of the accepted behavior, it would have been automatically blocked, which eventually means that when I give the credit card detail, it will only go to the malicious JS will not go to the attacker, right? So that's pretty much how the protection works. So let me show that part at least. Hopefully that works. So this is my card side. This is now behind my Aptrana. So now when I try to log in here, so what you see is the other behavior, the normal behavior which you saw in this site was allowed. But the abnormal behavior of that stealer.js getting loaded, that was automatically blocked because that was not part of the accepted behavior. So now when I give this credit card details, these details would not be captured and sent to the hackers. So that's pretty much how the uh, browser-based protection works in Aptrano. So let me show that. Let me tie that up all in the portal and show you how that everything works together. So, oops. Okay. So this is my portal. I have onboarded these sites behind Aptrana already. So let me show you how these things will work together, right? So now the first site that I have onboarded is my, sorry, I have some widgets here which I need to move around. So okay, the first site is my store dot. This is a site which we have not onboarded. This is the unprotected site, but I have onboarded it and I have put it in essentially what we call as the learning mode, right? So at this point we have learned that a JS is there. The vendor.qa.infra is loading this analytics.js, And you can also go and look at the references here or on what it is getting loaded. And once you have talked to your application team and everything, you can allow this, approve this JS, and then move this protection to enable mode, right? So that's initially you are in the learning mode, and then now you are enforcing. So what this means is you have verified this is the behavior. You know these are the JavaScripts that needs to be loaded, and then you have approved that hey, this is my known behavior. All this learning happens invisible to you. We do it as users use your product and you use your applications behind us, and then we keep listing it here, and then you can look at it and allow it, and then start the enforcement mode. Once the enforcement is started, what will happen is like you this is a site that is already behind AppRunner with all the enforcements. You can see browser-based protections also enabled, and this is enabled. So now in this case, it's the same behavior, right? So you have analytic.js, but a malicious request, a malicious JS is also now embedded in the analytics.js. So between last time when you had approved it, there was a change, right? Change in the JavaScript. So you will see an alert saying that, hey, the script has changed, right? The script has changed. And this alert will come to you immediately as we see any tampering of the scripts that you have allowed. And if you go and look at the reference chain also, you can see that the stealer.js is blocked, right? So the blocking happens seamlessly. It gives you, so you are, even though you are not aware of the JS is changing as Aptrana, as your end users loads the application at the browser, they get to know that hey, the JavaScript is changing, and they get to uh, 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 Aptrana gets to know that JavaScript is changing, and it gets immediately blocked. You get notified, and you can now go and talk to your application team, try and understand what is happening, and what you need to do to either you remove the third-party component or you figure out what needs to be done. Until then, this will be blocked, and then you can come and take any corrective actions as you need it. So this is how the entire client-side protection works. I hope I was able to give you a good idea on how client-side protection, browser-based attacks happen, and how we protect against this using our client-side protection solution, which is part of our app runner. So with this, we provide a comprehensive protection against supply chain attack. We already protected open source components. We have already protected databases. We already protected against leaked passwords and the likes. And now we are also having a protection against browser-based attacks, ensuring that we are giving a comprehensive protection to our customers against supply chain attacks. So, as best practices, what we suggest to our customers or to anyone who asks us how to go about protecting against supply chain attack, because the first part that you should do is do a discovery, understand all your application, understand all the third-party components that are part of it, get the inventory of it, do real-time scanning, ensure understand the risk posture across your application, across your third-party components, implement protection against this, and also have a browser-based protection that will help you against attacks, as I demonstrated as part of this webinar. So another major reason why you should be taking a serious note of this is because this is also kind of driven by some compliance needs, right? So if you are in an industry where you need to you are serving any financial uh, customers or financial industries, or for any reason you have credit cards stored or credit card data going through you, you need to be PCI compliant. And if you are already PCI certified, then also if you are going to get your certification renewed, now you need to get it renewed at PCI DSS 4.0, And because it is PCI DSS 4.0, one of the requirements of 4.0 is that have some form of browser-based protection. So 6.4.3 talks pretty much about this. It tells you that you need to have uh, some way or form to confirm the scripts that you're loading is the script that you have authorized. You have ways or forms to see that these scripts are not tampered. You have complete inventory of it. You have an approval cycle. And if there is tampering of this, you have ways to protect against those. And also on the server side, when a request comes from a browser, you are able to check whether the HTTP is tampered or not, and ensure that there is no tampering happening. All these things are automatically protected when you avail Aptrana. So we would cover you for 6.4.3 and 11.6.1 requirements, which is part of PCI DSS 4.2. So before we go further, just wanted a quick poll question. Do you want to do a free trial for Aptrana? The poll will start now. Great. We'll leave this poll open, so we'll go about talking about the rest of the slides. So just to summarize, right, as part of the client-side protection, essentially the browser protecting in the browser-based attacks, what does Aptrana do is it helps you get the inventory, understand as you onboard an application behind Aptrana, we learn, we understand what are the JavaScripts that are part of your application, what are the third-party components that is getting loaded. We give you the inventory. You can then monitor those inventory, get an approval done after discussing with your applications team, and then go out approving it. Then from there onwards, the Aptrana protection kicks in. We will constantly monitor any of your end users as they load your application at the client level, at the browser level. And if there are any changes in the scripts and everything, automatic alert will come, and the protection for it will immediately start. Our support is also 24/7. We provide this platform as part of our managed service. So as part of our platform, you can also reach out to our support system to get any further help. So they'll be always happy to monitor what is happening and give you feedback around these. With all this, you can have a complete protection against browser-based attacks like MageGuard, form jacking attacks, and the likes, and have a peace of mind. So this is pretty much a final slide. I would just for people who do not know what does our Aptrana web platform contains, I just wanted to give you a high-level overview on what we do. So Aptrana is a web application and API protection platform. It's a AI-powered, fully managed web application API protection solution. So we are the only vendors who start from discovery, do risk detection, risk protection, help you in compliance, and do a managed service. So let me give a bit more, talk a bit more deeper about this. So what do I mean by discovery is we do a discovery of your external facing assets. As you onboard, we look at your organization from the internet and try and find what are the domains that are associated to you, what are the assets which are part of the domains, what are web applications, APIs, mobile apps. We discover all these assets, give you the visibility around those. And as you decide which of these applications needs to be protected, you can onboard it behind Apprana, where two things will happen simultaneously. One is the risk detection part. We have our own dash scanner, which is integrated, which will help you identify the risk posture of your applications, help you identify the vulnerabilities that are part of your application. This is also complemented by our manual pen testing team, which will help you identify the business logic vulnerabilities. As these vulnerabilities are identified, the protection also starts. We give you the visibility on how these vulnerabilities are protected, what the protection, what part of these vulnerabilities are reported, what are not. And this is also backed by AI-driven DDoS and bot protection. We are also the only vendor who provide a Swift comply, which is essentially a path breaker in this industry, where with a single click of a button, you give a clean vulnerability report. So what we mean by this is we do the scan, we see there are vulnerabilities there. Some of these would be already protected by the WAF policies. Some would not be, right? You can click a Swift comply button and a request will go to us. We will look at these vulnerabilities. We will see how these vulnerabilities can be patched by writing custom policies at a WAF level. We'll write those policies, then run a scan through WAF again, ensure that all these vulnerabilities are patched, and then give you a clean report saying that, hey, all these vulnerabilities are patched. And all those things we do within 72 hours, it's part of our SLA. So this report is being widely adopted by our customers, ensuring that, and this is used in various cases, right? One is for any of your security needs, say you need to share this to auditor, the auditor is asking for a clean report, you can share this, right? It could also help you become an enabler of a business. So say your business is launching a new version of your application, you have found vulnerabilities. Now the general practice would be you will be forcing the application team to fix those vulnerabilities before going live. But instead of that, you can avail the Swift Comply feature, get those protected, and then move on with life. And in after some time, when your application team finds time, you can fix those vulnerabilities at a core level. So that's our key USP. And also we back all this with our managed service, which includes false positive monitoring, right? So all the sites that is behind Aptrana remains in block mode. 100% of applications are in block mode. And it is because of the managed service we provide, where we do the positive monitoring and fine-tune the application based on applications. So that's pretty much what we are, and that's what we provide as part of our Aptrana. Aptrana helps you protect all your web applications, APIs, and mobile apps. We have a strong API security solution also. The risk-based protection extends to APIs also, where we identify the vulnerabilities and protect those. We also do API discovery, and we also have a positive security model to protect against APIs. So we are the only platform who provides a comprehensive end-to-end protection for your web applications, APIs, and mobile apps. With that, I come to the end of the webinar. Open for questions.
Yeah, Vivek, looks like we are out of time, so we'll just take one question. So this was like, okay, what is the WAF's role in this, like Akamai and Cloudflare? Maybe the question was, uh, what they do, and if
We are similar to Akamai and Cloudflare, right? So they are our competitors. Obviously, we do a better job than them when it comes to protecting the applications. We provide a fully managed solution. That's why we are able to make 100% uh, have all our application in block mode, and but the features like the Swift Comply I explained are the key, right? So that's essentially a differentiator between Akamai, Cloudflare, and the likes. I hope that was the question.
yeah. Yeah, I think thanks so much everyone for joining us today. So for on those questions where we haven't been able to get back to you, we will reach out over email. Yeah, so we have these monthly webinars. Please feel free to join us. And yeah, have a great rest of the day and the weekend. Thanks so much. Bye bye.
Bye bye.